Welcome to Scaling Solr in the Cloud. We've been using Solr now for maybe about 6 months, and kind of what we're going to share today was a little bit about how we use it very briefly, and then kind of how we scale it to actually work for our needs. And then, this probably isn't all the ideas that are out there, so if we get through this and you're like, wow, I had some other ideas that these guys didn't have, you want to stick around. It'd be really fun to kind of talk them out and see if we can do more as we work together. The first slide, this is just kind of like the agenda. We'll talk about a little bit about Andy. My name is Lindsay Snider. This is Andy Blyler. Nutshell is where we use Solr, kind of how we use it, where we think Solr's resources kind of are constrained, which kind of leads into how you scale it, and we'll do a little Q&A. So Andy and I both got our starts at a company called Bitly, which was an offsite backup technology. It would take data, back it up from your servers, send it up to the cloud, and it was an offsite backup solution. With an offsite backup solution, you got a lot of data in the cloud. So that was kind of our first experience in scaling stuff in the cloud. So it kind of led into the next company that we're now a part of, Nutshell, and how we had to scale some of that. Nutshell. So Nutshell is a web mobile CRM. Have anyone heard of Nutshell? Probably not. Have you heard of Salesforce? Yeah, everyone's heard of Salesforce. Okay. So it's a competition with Salesforce. Of course, with Salesforce or any kind of customer relationship management software, there's a lot of things you have to search for. We picked Solr for that, but there's kind of our development stack there if anyone's interested. Gen2, Index, PHP, MySQL, Solr. At Nutshell, we use Solr in some interesting ways, maybe some ways that are untraditional to how other people might use Solr. In addition to that, for example, with data dedupe, you'll see a little bit of that. We also use it for the iPhone app. The iPhone app actually has an API baked right into the back-end equipment up at the Nutshell cloud, and a lot of the searching you've done on the iPhone app is type as you search, and it's actually going through an API and doing type as you search up to the cloud. We have a little tiny demo for that. So I thought before we got started, these are really short. They're like little 40-second demos. That's kind of how we're using Solr, and it'll give us a little perspective of how it fits into this topic. So this is the first one.
Nutshell's native iPhone app lets you keep up with your leads and log activities on the road. Use the fast find as you type.
So this is a search that's actually hitting the website, hitting Solr in the background.
Or check out your latest leads. Building a new lead is easy. Enter accounts and contacts, and Nutshell will check for duplicates as you create them.
It's all done through Solr.
Products, competitors, or sources, then save your lead. Sales processes and assignment roles are automatically applied. Schedule new activities from the phone, setting dates, participants, and location. The activity is automatically synchronized to your Google or Exchange calendar as soon as you tap Save. When you completed an activity, like meeting a client or making a call, logging from the phone is a breeze. With the world's first mobile media logging, you can skip the keyboard and record an audio note or a video clip.
Hey team, I just got off a call with our primary account. I'm walking into the office.
The media logs you take can then be viewed by any team member via their iPhone or web browser. Finally, you can use the innovative timeline view to see a comprehensive history of interactions with a lead. Each email, note, and activity is displayed in an easy-to-browse chronological list. Tap any row to see more information. We're constantly working to improve the mobile Nutshell experience on the iPhone and other platforms.
Yeah, so the one reason we put this video up is because it's interesting that even on the iPhone we're using Solr, so it just puts even more load on the Solr system. 2 more short videos, these are actually smaller. This is a video on the data deduplication. So instead of using MySQL, which might be the thing, or your native database that your data is stored in to do the comparison search, we actually do data duplication. They typed in Quicksilver, they really meant this Quicksilver, and rather than let 2 entries in, we used Solr on the back end to find that there's a match and merge these 2 entries together. This just shows the entries. And then on the next video, this is the, how do you do this?
Yeah, this one we're actually showing how we're using like a phonetic matching to actually look for, like if you're typing in Mike, it comes up with Michael. You can notice just how fast it is for Solr to return these results. Now we're searching for home, and you can see it's actually matched on KB Home, where home was last, but then it also matched on Home Depot.
Okay, so this kind of gets into, okay, so how do we scale solar? Well, this is an interesting way I like to think of a computer. Like a computer provides resources to you as a consumer of the computer. And these are the 4 resources that I consider a computer provides. It provides CPU power, it provides disk I/O, it provides disk storage, and I think there's a big difference between the two, we can talk that out, and it provides RAM, right? So those are the 4 things, and when one of those runs dry in your computer, you're kind of done, right? It runs out of disk space, you need another server. It runs out of CPU, you need another server. So what's going to run out first on Solr is kind of the thing we need to fix, right? Or this thing we need to prove to make it scale better. So I have a little chart over here, and we just kind of go through it, like how much does Solr use CPU? It actually doesn't use a whole lot. If you watch the profile of it, well, how much does it use disk I/O? Again, not a whole lot. And the reason I think it doesn't use a whole lot, and maybe this is just an R implementation of it, is because it doesn't use much disk storage. So because it doesn't use much disk storage, it means most of the Solr index is in RAM already. So if it doesn't do this very often, it's very quick. So where is Solr a beast? RAM. RAM's the big one. And that's the thing that was running out first for us. So that's the thing we worked on fixing. So the next couple slides will show you how we fixed it.
Do you want questions in the middle or at the end?
Maybe at the end, unless they're really relevant. Yeah, let's do it at the end. Okay. So up here you see a little time bar, and we kind of separated this into the Dark Ages, the Age of Enlightenment, the Modern Era, and today, on how we kind of grew through our Solr knowledge. And the Dark Ages there's kind of 2 things we did in our Dark Ages. First, we set up auto provisioning. Of course you do that when you have a new app and customers sign up and you do auto provisioning. So it automatically got set up, we populated the MySQL data, sent a welcome email. And then the second thing, well, how do we auto provision it, I guess, is we had a separate Jetty instance per customer. So we're using Jetty as the server daemon here. A downside to it was it used a ton of memory. It had a separate schema for each Solr user, but it was the morning before the launch that we realized that this thing was not going to scale. And I don't know, has anyone been in the situation like you're at lunchtime and you're like, oh geez, everything we thought was going to be fine, this is a really big problem, right? So the time between the Dark Ages and the Age of Enlightenment was shrunk very small out of necessity. It was probably overnight. But I have a little graph here, and it's going to progress as we go through the presentation. Dark Ages got us to about 50 customers on a server, which doesn't sound bad unless you're very successful or you got email options, then it's not very many at all. Dark Ages, 2 things, auto provisioning, separate Jetty app for each customer. Age of Enlightenment, we had to make big changes, it's launch tomorrow, only 50 customers. What if we get 300 tomorrow? Well, we don't have enough servers at the colo, it takes a week to get it. So we actually have 3 different things we kind of learned here. One is Solr core per customer. Is anyone familiar with Solr cores? Yeah. So a Solr core basically is, if I were to jump back to the slide before, we said we had a separate Jetty instance per customer. So you hit it on this port, you get customer A, hit another port, you get customer B. Solr cores is you have one Jetty server, and within it, Solr can segment your indexes per customer inside of one Jetty server. So you get to share some memory there. Same in a single Jetty app. So lower memory usage. Again, just to repeat back, scaling Solr for us was all about lowering the memory usage because that's the resource that ran out first. Second thing we did, and this actually does play into scaling Solr, is that if for some reason Solr didn't work out, it automatically falls back to MySQL. Because everything Solr can do, MySQL can kind of do a half job at it, right? So at least you have a little bit of fallback there. And then the third thing, and I'm not really sure why, but when we switched from Sun JVM to Ice-T JVM, which is an open source fork of Sun, our memory usage went down a lot. And as far as our research can tell, they're 99% the same. Maybe we just got lucky. I don't know, does anyone use Ice-T or Sun? Have a preference over the two? No. But that helped us. Yeah. So what did that get us? We did those 3 things, and here comes this graph again. We went from 50 customers in a box all the way up to 300. So that's pretty significant.
So after the Age of Enlightenment, we moved into the modern era, and we had three things that we did there. The first one being sharing the schema across all the multi-cores. So we used the multi-core setup, but we didn't actually tell it to share the schema. We actually found that sharing the schema amongst them all decreased the load time, because what would happen is we would go and do some sort of maintenance update Solr or something like that, stop it, start it up, and all of a sudden the load time took minutes to actually get it up and running. Sharing the schema helped out with that, and also helped out with lowering memory usage. The second thing was we went through and we had a bunch of fields that we were actually indexing to make searchable within the index that didn't need to be, because one of the things that you were seeing on some of those demos was the table views. We actually use Solr for pagination and for the display of the data within those tables. So going through and actually making the fields that we use for searching, make those searchable and make the other ones unsearchable, helped a lot. It actually, I would almost say, cut our memory usage and by a fourth. The third thing was the splitting of the reader-writer role. One of the things that we do is we allow users to import like a CSV file, that they got from Salesforce or they got from Share CRM or wherever. And when they upload it and they go through and they say they match these fields up and all that sort of stuff, then they click import. Well, when it's clicking import, it's importing all that data into MySQL, but it's also creating, putting this data into the indexes. And one of the things that happens with that is we would notice that as soon as somebody was running an import, a couple people running imports, and all of a sudden the system seemed to get a little sluggish. And that was just from it building the index and going through all those steps. So splitting of the reader-writer role helped out a lot with that, because then your writer, where you're actually doing the index manipulation, it's all happening there. And then basically the way that Solr does the replication is almost like an rsync. So it builds this file and then just copies it over, so it doesn't have to do all that work. And on the writer, you can turn off caching, so it doesn't actually cache anything. It's just performing the writing operation. So that helped a lot. One of the, just to sort of show, you can see some of the spikes on this graph, and that's probably times where people were doing imports. You can actually see what our read query time is relatively low, 2.11 milliseconds. And one of the interesting things while digging through the logs, coming up with the information for this talk, was we do a fair amount of writes. We almost do more writes than we do reads, just because of you go in there and you're acting on a sales process. You're changing data all the time. You're changing data almost as much as you're reading it, especially with all the imports that are going on with new customers, signing up.
This slide is kind of interesting because our assumption going into this before we made it is that we would find we're very read heavy, and you would try to optimize for that, but it's just not true. Right?
What's the y-axis? Queries or?
Yeah, I think it's queries per second.
Yeah.
And I guess it writes documents per second or something.
Well, it's probably writes per second. Yeah. It's a read of a.
It's basically like the queries, so a query per second that is being executed. So this is actually a diagram that sort of shows you basically what I was talking about, but also how it happens just through the normal web application. How does an index get updated? So one of the things that we actually do is you go through the web app. The web app is going to talk to the MySQL master. That's where it's going to do its updating. It's where it's going to do some of its selects, but it's also going to get information from the Solr slave. And the Solr slave gets that information from the Solr master. When somebody updates something on the website, it's going to talk to the master, but it's also going to talk to, we use gearman workers. So it's going to fire off a gearman job. So that we're not actually asking Solr to update that index within that web request. We're making that asynchronous and have it happening in the background, which helps increase performance to the end user. So after the gearman job fires off, and it could fire off other jobs too. Maybe you're updating a lead that also has to update the contact or account. It's going to go ahead and update the master, and then the master is going to replicate to the slave, and then that's where information would come from using the iPhone app or using the web app. We also have the concept of reindexing. So I think we'll touch on this a little bit later, but we have the concept of marking an account for reindex. So even if the account, like let's say Solr wasn't running for whatever reason for that customer, we have the ability that when we do an application upgrade and we want to reindex all the customer base, because we're indexing a few more fields, we just added. You can flag the account. What will happen is we will send to the reindex manager. We'll say, one login, go ahead and kick off a reindex for this customer. And it happens fairly quickly. It will go and it will fire off a whole bunch of gearman workers. Those gearman workers will go out and it will start pulling down the data from MySQL for each of the different information that we store within Solr, and it'll start pushing it to Solr master. So
I was going to say, just a place to pause on how this relates to scaling is we found that when you do have to hit Solr hard via reindex or an import, it kind of really slows it down. So in this model, we beat on the master when we do a reindex or an import. And then the sync up to the slave doesn't put a whole lot of load on the slave. So the slave can hand up queries under not a whole lot of load. The load's hitting the master and then replicating up. So this guy's doing all the work and just handing it off to this guy. So we actually got a big win in this model.
Did you use the HTTP replication, or were you doing OSCon rsync?
I believe it's OSCon rsync. So that sort of goes through, the modern era, and you can see here how we're building up, and now all of a sudden we can scale up to, 1,000 or so customers on a box.
Yeah, each era is a pretty big win. I mean, we started at 50, and now we're already up to 1,000 just with these few things. I guess there's...
Yep. So today we do a few things to actually make it even better. We have an intelligent core management. One of the things that we found is you have people signing up for accounts, and we, like Lindsay was saying, we create a separate core per customer. Well, what happens when that customer doesn't log in for 3 weeks because they're on vacation, or maybe they were a trial account and now they're not using the system, but their trial period isn't over yet? There's all sorts of situations where we have all this information in memory, this valuable resource that doesn't need to be there because the user's not actually using it. So we came up with some scripts and stuff that we run on a regular basis, and it will spin down the cores that are not actually actively being used. Once the user actually logs in via the iPhone, via the API, or via the website, it will go ahead and start up. In Solr, it takes less than a second for us between the time that they're logged in to the time that it actually spins up that core. So it's very fast. When people are storing stuff in CRMs, it's not, the index isn't very large, but we have a lot of indexes, and that's where we needed to scale. And then also sort of what I was talking about before is you can put the reindex flag on the customer account and trigger the reindex and login, and that sort of plays into this whole intelligent core system, because we can't just on upgrade go ahead and reindex everybody's customer account. It would take hours for one, and for two, their Solr instances might not be started, and they might not be using it. So why reindex their system if they're not an active customer? Other thing we did was partitioning. So taking the reader-writers and putting them into pairs, and then putting certain accounts against certain pairs of reader-writers. And what this allows you to do is to, it allows you to scale, allows you to have more machines, which gives you more RAM. And we have a slide that goes over this next. So what did that allow us to do? You can see it's getting very small in the scale here, but it allows us to go up to about 8,000 customers per server.
50 to 8,000, pretty big win.
Yeah.
So what happens when 8,000 is not enough? We have any more tricks left, and 8,000 we need to grow beyond that because we're very sensible or whatever. I'm sure a lot of you have done this before, but this is where you get into starting. Just make a bunch of them. If anyone wants to clear a chap, and I'll clap on all these automations I did for you guys last night. I had a lot of fun. It's probably not the most useful use of my time, but I thought they were fun. So yeah, you create a bunch of these servers, right? And so how do you address them? Well, you have them sitting over here to the side, and what we do, and I think this is pretty common, we take their account number, This is me messing up now. There. You take their account number, and we look at it backwards. So the count 1, 2, 3, 4, 5, 6. We go backwards. We look at the last 2 digits. You can look at 3, 4 digits, whatever. The 5, 6. But again, we're reading it backwards. So you come up with this number 6, 5. And then you have these reference counters over here to the right. And we say 6, 5 goes to that Solr server. So then with this setup, if you're looking at the last 2 digits, you can have 100 Solrs. So at 8,000 users, you get 800,000 users on this setup, right? But you can look at 3 digits and have 8 million and so forth.
So does that mean that when you add additional servers, you have to rebalance all the cores?
Next slide. Good question. So what if we decide that this server, the 9697, this guy, he's too busy, right? We need to rebalance that. So the first thing we do is we set up 2 new Solr servers. One there, one there. So we got 2 new Solr servers. And then we set up replication from this Solr server to this guy. So everything that happens here comes up here, everything that happens here. So these guys are doing the exact same thing as the first ones, right? So you got 3 guys all doing the same thing. Then when he's all synced up, you change the pointer from 96 to this guy, and you change the pointer from 97 to this guy, which does the live cutover. You can do this while customers are hitting, we didn't drop any packets or anything, and then we just tear down that one. Now we got twice the capacity, and we did it inline live, and you can just keep doing that forever. So
you bear with me. That
Sure.
means that if you've got, like one of the earlier Solr machines, and when that, you had a spike of users that were trial accounts that didn't go anywhere,
Yep.
then we just need to try to condense them.
Yeah, so with the trial counts, you can try to spin them down. But if you find that, hey, all the accounts that are on this box are useful, I need to keep them, what I really need to do is farther partition so that this server is not responsible. If you remember, this is actually the end of their serial number. So this box is responsible for every serial number that ends in 69 and 79. Now I'm going to have one server that is just responsible for the 69 and one's just responsible for the 79. So they're now doing half a load.
How's the opening from just split servers?
Well, so once you've changed the pointer, so that this guy's only doing 69, this guy's only doing 79, you go to this guy and delete all the, well, I'm going to put here. You go to this guy, delete all 97s, and this guy, delete all 96. Once you change these pointers, that lookup table, the people that hit the 97 are only coming to this guy. Right? They're not going there anymore. So the load is split. And after the load split, then you can go back and remove the cores that weren't not supposed to be on there, or the data set supposed to be.
So what happens when you hit a very large number for account IDs? You've got, 121,000.
Account IDs?
Yeah, let's say you hit like 44 million, users.
Yeah, sure.
They all petition the same systems before you federally.
They won't. The reason they won't is because we're looking backwards. You look backwards. An account number, you have the most entropy at the end.
Yeah, but you said you reversed it. So like the last 2 would be 44 a whole lot. You have like 44
They'll be 44 every 100.
You're using the least significant digits, not the most significant digit. Right?
Yeah.
And
Yeah.
so the least significant digits, not the most.
So if you looked at, let's take the million, the number 1 million. You look at the first 3 digits, it's 100. 1 million and 1, first 3 digits, it's 100. So if you're looking at the beginning of the number, it's not changing very frequently. Now let's take those 2 examples I just said and look at the last 2 digits.
Oh, I'm sorry. I thought I actually saw you said that you reversed the account ID.
No, we just look at it backwards.
Oh, okay.
Yeah. Okay.
We reverse like the last 2 digits.
I got
Yeah.
you.
So you have the most entropy. Cool. So that's the talk and the stuff we did. I mean, this is just kind of a nice ending slide that talks about the 4 different errors and how far it got us on each one. And then beyond this, you do the chart. So any questions? Or what would also be fun to talk about is other ideas people have that we should all consider?
I was just kind of curious, like how many machines you guys have, like how many indexes and how many voice percentages, stuff like that.
Yeah.
So,
I don't know if we could talk about size. but we just we try to stay ahead of it and add them as you need it.
Yeah.
So you can use like graphing packages in Nagios. Did anyone use Nagios or Cacti? Sure. So you can take like something like Cacti and graph your server and watch its load. And once it gets above a certain point, that's when you can install another pair of machines, split the load in half, and kind of keep on track.
There's like an average document index size.
We actually, it's surprisingly pretty small. Even a pretty large customer doesn't add up a lot of data when it comes to index size. And that might be our use case. Like if you were an email provider and you wanted to make your email searchable, your index size might be larger, which will change your numbers for sure.
Why not use just a simple wrapper on the receipt while you have the Solr?
Yeah, I mean, it's probably just a trade-off between what you write on your own versus what you take for free.
Yeah, the big benefits that we get out of Solr is like the multi-core support. Having it manage that, and just having a basic, HTTP API that we can go to spin up new cores, shut down cores, get a list of cores. It just makes it nice to be able to have that sort of wrapper around it.
Doesn't Solr also add like the word stemming and sendings for your search?
Yeah, and it also adds, a few other features that we can use.
Which is some of the stuff that
Well, the stemming is a Lucene function, but it exposes.
any other? Yeah.
When you're writing to an index, those changes are not available to the currently open readers after that?
The currently open reader?
Yeah.
I'm not sure. So in our application, it's kind of okay if there's a few second delay from the time that you insert something to the time that it's searchable.
Yeah, we use like the delayed commits feature, so you can say like we want this to be committed to the index within like 3 seconds, upon write. So then we give Solr the option of, hey, if you're ready to flush these down, or if you have a few more changes you want to bulk together. So we sort of let Solr. But in other places, we do actually tell it, commit. They're doing an import. When the import's done, we want it to commit right away. But other operations, we let it have a few second lag.
And what I was getting at was, what's your strategy for reopening your readers? Is there any cost to that, or is it a light operation?
It doesn't seem to be too heavy of an operation for us. It hasn't caused us any issues.
Yeah, the data's on solid memory at that point. Really do everything you want. What version of Solr are you doing?
What's the latest one that they just came out with not too long ago?
3.1.
Yeah, we're using.
They went from 1.4 to 3.0.
Yeah, I think we just recently went to 3.0.
I think we saw a memory drop when we did that too. I think they might have come up with the optimization in the latest version. That helped.
When you upgraded, did you delete all of your indexes? Like how did you do it with this?
So that actually goes back to the slide where we showed that we kind of re-index out of band. You can set all the accounts that they need to be re-indexed, but you don't force it all right now. So the next time they log in, you kick off a re-index, and you kind of do it over time as they log in.
That's exactly what we did.
Why did you choose having many cores as opposed to having like one flat core and those namespaces or documents?
Yeah, I think the main reason we did that was just the ease of management, and also, whenever we need to start up or shut down, otherwise we just keep growing, and it wouldn't really, you could do it that way, but allowing us to be able to shut down, start up, decrease the memory usage just from not having all those indexes.
Control exactly what memory you want in, and it also makes it easier to get rid of it later.
Yeah, we don't have, what would happen if we re-index it? We'd have to re-index the entire customer base. We couldn't just start from scratch, and it just has a lot of benefits for having it segmented out on a per customer basis.
I mean, two things I kind of just wanted to point out. I'm an engineer at SC, we use Solr a lot.
Sure.
We have a lot of traffic going through it. I think two things that jumped out that might be interesting to you guys. So the first is kind of a minor thing in that it sounded like the state of your index right now, you guys do still use stored fields, and you kind of pull some of the data out of the index to render, is that right? So I mean, I think it might be a win for you guys if you eventually just pitch the stored fields, and then you can get your document size really tight, and then obviously index that you have on the machine, then just use memcache to just pull the objects which you get IDs out of the index. It's kind of a small thing. The other thing that you guys might find interesting though is that we actually had a similar architecture a while ago. We weren't using Gearman to do the updates. We were using ActiveMQ, and we found that it was like actually quite difficult to wrangle all these moving parts. I mean, you can do it, but like we had so many times where like the queue would get backed up, and then like Solr was behind and all these things. And so we kind of stepped back and thought about like what our latency requirements were, and we felt that, you know, in general, like having a little bit of latency on the index wasn't a huge deal. So we basically pitched the entire queue, and what we ended up doing was just having an incremental indexer that runs and just does a select off the live database of the last tail of the updates and stuff like that. And so
Just run that on the schedule now?
Yeah, and so it seemed like kind of one of these things that was a step backwards from like a systems engineering point of view, but practically speaking, it greatly simplified the system without really lowering the overall requirements, and it's just kind of like made a huge headache of ours in a way.
I guess you're going to re-index, then you could just tell it to select from the beginning too.
Yeah, when we re-index, yeah, we pull everything out. It's kind of a big problem.
The one nice thing that we did with Gearman was we set up Gearman to have a persistent job queue, you know, one disk. So, you know, as soon as it goes in, it's persistent. So even if Gearman gets restarted, we're going to start that job again. So it's sort of nice that we don't have to do any querying; it just sort of magically happens. And also on a re-index, we have that re-index master, which is essentially like a Gearman process that then kicks off a bunch of other jobs and waits for those jobs to finish before it sends the commit to Solr.
Yeah, that's a good point though. Anytime you consider removing a queue, right, you're taking out one working piece.
Yeah, I mean, our architecture at NC is like really heavily reliant on sharded MySQL, and kind of our philosophy is like, you know, we can put load on those things, and as long as the load is like not something that's like moving our graphs, you know, we're totally comfortable with it. So we're in a situation where we can do those, you know, pretty, you know, fairly heavy duty selects, but we have these monster machines that are handling them, and so there's really only a small percentage of our IOs in those boxes. So just really missing the part.
You've probably got like a really large document base, and if you're, you know, even if you're doing like sharded, you know, like catalogs of information for products, how often do you have to like re-index them or?
I'm not too sure if we have like a fixed. We don't really regularly re-index things on purpose. It's usually in reaction to, you know, schema changes and the usual type of stuff. Yeah. But yeah, I mean, we have about 10 million items on the site, so about 10 million documents that are indexed. It's not really a monster.
Yeah.
Does anybody want this slide deck?
Yeah, we're going to post it to the OSCon, you know, site as well.
So we have like 400 million documents that we deal with. And so I work on the World War Packet and the community sites. So we index almost 1 million foreign posts across the community sites, plus characters, guilds, and teams, and all the other information. So we, like, if we did that batch operation where every 10 minutes or 30 minutes we waited on stuff, we'd have, you know, possibly 20 on peak times, you know, possibly 3 million things that we could index. So we have some weird requirements for doing like a very constant number of updates over time. Which I was interested in having a shard and maybe some of that stuff.
How do you guys do it?
Blood, sweat, and tears.
Yeah.
You guys looked at Solr Cloud because that's what uses a Zookeeper to do the sharding automatically. I haven't used it, but
We are super interested in that, but it's, so from what I've read, it's on Solr.
There's another one we heard is Cassandra and Solr all mashed together.
Oh yeah.
Salandra or something.
there's also HBase.
Yeah, so we looked at that.
Yeah.
That has its own set of issues. It from digging that code base, like it sort of jerry-rigged Solr to think that it's a separate loosened backend that's fake. So it's fucking weird.
Yeah.
We looked at Elasticsearch, but that also has its own set of
I mean, what we do is very traditional. I think a lot of people do it. It's been around for a while. It works really well. I guess you got to do some stuff by hand, but at the end of the day, you got a pretty easy solution to manage. Let's go.
For the space that I'm in, we have to index our customers' data plus data from their social networks.
Yeah.
So you've got overlap, significant overlap between your customers' data. Any thoughts on what's the right way to handle that? Things like one big index versus some others?
So per customer, you might want to get data.
Yes.
So it's two operations, but I guess before you did an insert, you could do like a select to see if you already have the data. Before we inserting it again, be one operation. Or you just insert it and be okay that there's two, and when you select it out, just dedupe it at that point. Depending on how read heavy versus write heavy you are.
Well, we'll have a crawler running, trying to keep all this stuff, be updated at least once a day. And then perhaps as soon as someone connects to our service, we might just quickly go see if there's anything new to just pull it index.
Yeah.
But the duplication scares us because the friends data is much larger than our own. And for duplicating that, I think it's very.
Yeah. Yeah, well, it probably makes sense. If you're worried about getting buried under it, then you maybe do a select before you insert to make sure you're not saving too much information. You might even have a process that runs once in a while that kind of just query and checks to see if we can find duplication and clean it out. You know, after the fact, comes with safety too. I guess it depends on your usage. Especially your downtime, right? If you have like, no one really logs in at 3 in the morning, you know, then you can take advantage of that kind of time to do that.
Yeah.
Yeah, right.
Not your people.
Yeah.
That's when your people are.
I'd say the World of Warcraft people, it's probably like 9:30 a.m. It's pretty quiet.
7 in the morning. Now if they pull the long
7 a.m. Depends on the rate.
For maintenance, it's from like 4 p.m. to 8 a.m. So that's what I'm sorry, 4 a.m. to 8 a.m.
Yeah.
We're international, so
Yeah, it's all the time
tough for
zones.
us.
Well, do you have each of your users or each of your customers partitioned into different cells like these guys do? Or?
Well, that's what we're just starting to look at. We don't know the right way to organize it.
Yeah. 'Cause it seems like even if the users are their social network, the social network data that's common needs to be some kind of common cell.
Right.
Yeah, that helps. I mean, it helps with latency if you keep like all the people in the Americas together, or in Europe together, or EMEA together, say, and the Pacific together.
Well, if we distributed the people randomly, if we had many solar, boxes running, and this guy has a friend network, say 100 people on one query, you could actually share that query out to get those boxes simultaneously.
Yeah. Yeah. That's something to consider. We haven't done much of. Distributing query between two, merging the results coming back.
Solr does
Solr
provide
makes
that.
that to you. Query within people using practice.
Does Solr do replication just for fault tolerance?
Well, I guess there's always a couple reasons for replication, right? The one is to have a warm spare for top fault tolerance, and two is since it's up and it's a hot spare, might as well read from it. And we found with Solr that there's actually a win. Like unlike, if you're write heavy on something like MySQL, your write to A has to write to B. So having multiple services actually help you because everyone has to do the writes. But if you read heavy, then you can actually get performance benefit off of reading up the slaves. You write to one, and you have a bunch of your slaves, you can distribute your reads across it. So it's probably two reasons to answer your question: fault tolerance and scalability if you're a read heavy application. Cool. Anything else? All right. Thanks for coming.